Okay, so let's look at a simulation of how this hypothesis testing really works. Here we have an example about Cramer's predictions. So there's a website that keeps track of predictions made by an individual or individuals in finance, politics, sports, and entertainment. This website kept track of 680 stock predictions by a financial personality and found that 310 were correct. We're going to treat these predictions as a sample of all of this TV personality's predictions. So, does the sample evidence, the 310 out of 680, suggest that this TV personality is correct less than half the time? Well, let's start by going through our process for our hypothesis testing. We want to first determine our parameter. So the parameter we're looking at, remember there's three choices. You either are looking at a proportion, where we're talking about qualitative types variables, a mu, where we're talking about quantitative, or sigma for standard deviation. And if you notice here, what we're looking for are the proportion of correctly picked stocks. So in other words, is the personality well, not is, but the proportion of times you pick the stock correctly is 0.5 because you either pick it correctly or you don't. So that's a 50-50 chance. Now, to verify the normal distribution, remember that's where we're going to take NP1 minus P. So our sample of 680 times the P, which is 0.5 times 1 minus P is equal to 170. This obviously greater than 10, so we verified our normal distribution. So let's see if we can come up with our statement regarding the population. The null hypothesis will always be our statement we assume to be true. So in this case, we're going to assume that the TV guy is correct in half of all predictions. So in other words, that the null hypothesis H sub 0 says that P has to be equal to 0.5. What we want to show is that he is correct actually less than half the time. So in words, that would look something like this. The TV guy is correct in less than half of all predictions, or in other words, that H sub A says that our proportion of correctly picked stocks must be less than 0.5. So we want to now simulate sampling over many, many different trials. And we're going to use that simulation in order to build this null model and see if we can figure out what our p-value is. Remember, p-value is going to be our probability of getting a sample, such as what you see on the screen up there, a sample of 310 out of 680. It's the probability of getting that sample or less if the true, let's say, assuming he's really correct in half of our trials. So I'm going to turn to StatCrunch and let's open up a simulation app there. So we're going to go to simulation coin flipping, and the probability of correctly picking the stock is still going to be 0.5 because it's pretty much the same as flipping a coin. And we're going to say we sampled 680 different stocks. So we'll flip a coin, if you will, 680 times. And I want to see if the number of stocks that are picked are less than our 310 from the example. So number would be less than or equal to 310 correctly picked stocks. So we hit compute and we have this simulation process here. And we're going to simulate this 5,000 times. So we're going to run this 5,000 times, and each of these 5,000 trials represent picking 680 stocks each time, And how many of those trials resulted in 310 out of 680 or less correctly picked stocks? And you can see that that only happened 53 out of 5,000 times. So, in other words, 53 divided by 5,000 ends up being 0.01. And we know from previous experience here that that 0.01 is, in fact, the probability or the proportion of times of getting our sample or less. So if we come back to our example, I want to interpret the p-value. The p-value that we're looking at is what we're going to use to help us make a conclusion about our assumption. But if I ask you to simply interpret our p-value, we're going to be interpreting probability as we've been doing previously. So, assuming that our TV guy is correct in half of all of our predictions, we would expect to observe 310 or fewer of those correct predictions only in about one of every 100 repetitions of the study. So here we're not quite making a conclusion about our assumption. All we're doing at this point in this example is understanding how to build that model, and then also how do I interpret our new term of a p-value, which in reality is an old concept of the probability of getting our sample.